Hi, myself Keshuse. I am from mechanical department. My topic is on choosing of anti-friction bearings in machine design. Introduction to choosing an anti-friction bearings. Anti-friction bearings are crucial components in machinery and equipments. There are different types of bearings: angular contact bearings, rolling element bearings, deep groove bearings. Anti-friction bearings are crucial for components in machinery and equipments. A proper selection of bearings is essential for optimizing the performance and long lasting. Factors such as load, speeds, operating conditions must be considered in bearings. Types of anti-friction bearings. There are a lot of bearings. Concludes some deep groove ball bearings, self-aligned roller bearings, cylindrical roller bearings, self-aligning ball bearings, bearing blocks, tapered roller bearings, trussed bearings, angular contact ball bearings, needle roller bearings. These all are the types of bearings and frictional bearings. A common types include ball bearings, roller bearings, needle bearings. Each type has specific advantage and limitations based on their applications. By choosing the right type of bearings is crucial for overall system efficiency. Load capacity considerations. Radial load. We can see the shaft any bearing. Shaft rotated between the two radial loads and the axial load. Load capacity considerations. Understanding the load requirements is fundamental in selecting the appropriate bearings. Factors such as radial loads, axial loads, and dynamic loads rating should be evaluated. Oversized bearings can lead to a premature failures, while under, undersized bearings may result in excessive wear. You should take the appropriate size of bearings to rotate a shaft or operating speed rotor balancing. Speed and operating conditions. Operating speeds and temperature ranges are crucial factors in bearing selections. High speed applications require bearing with a low friction and high heat dissipation capabilities. Harsh environments bearings with enhanced corrosion resistance and lubricate properties. Rotor shaft blows, wheel seals, damaged bearings, and even rotor failures can be a result of excessive shaft vibrations caused by unbalanced industrial applications. Offers the operating speed balancing programs and solutions. The potential problems located in tensions. The bearings choosing a right speed rotations causes a many impacts, component failures, long period of storage, or indirect erosion of corrosions, lost or endurance balance weights, scaled buildups, process upsets, seal rubbings, alignment changes, and loss of sink fits due to components relaxing during the runnings, excessive shaft runouts, shorted windings on generative rotors. Lubrication requirements. Proper lubrication is vital for reducing the friction and wear in anti-friction bearings. Greases, oils are common lubricants used to ensure smooth operation and prevent permanent failures. Over lubrication or under lubrication can lead to overheating and bearing damages. Environmental factors. Environmental conditions such as moisture, dust, and contaminants can impact bearing performances. Sealed and bearings are recommended to harsh environment to prevent integration of foreign particles. Regular maintenance and inspections are essential to ensure bearings remains operational in challenging conditions. Environmental factors in laboratories: temperature, humidity, air conditions, and vibrations. Compared to a regular workspace loop, laboratories have a special environmental requirements which should have considered during the processing by maintaining the integrative experiments. Installation and mountings. Correct installations and mounting procedures are crucial for long-active and anti-frictional bearings. Improper handling and misalignments during the installation can lead to a permanent failure. Following manufacturing guidelines or using a proper tools are essential for successful bearing installations. Maintenance practices. Regular maintenance and inspection schedules are necessary to monitor bearing health. Monitoring of abnormal noise, vibrations, or temperatures can indicate potential issues. Regression, relubrication, and bearing replacement should be done as per the recommended intervals. Cost considerations: time, scope, and cost. Balancing performance requirements with budget constraints is important while selecting a bearings. High quality bearings may have a high initial cost, but such results in low maintaining expensive in long run. Consider the total cost of ownership including the installation, maintenance, and downtime when evaluate bearing operations. Time, delivery delay, new deliverables, poor estimating scopes, additional budget reducing delay, scope creep, poor planning, cost pre changes, staff changes, and etc. In cost considerations. Application specific considerations. Tailoring bearing selections to a specific application's requirements is crucial for optimal performance. End plate shaft. This is the shaft which consider of bearings. Factors such as shock loads, misalignments, and mounting should be taken into account. Consulting with a bearing experts or manufacturing can help in choosing the most suitable bearings for the applications. Industrial standards and regulations. Compliance with industrial standards and regulations is important for ensuring the safety and reliabilities. Bearings that meet international studies such as ISO's NISS are preferred to quality assurance. Understanding the regularities, requirements, and certifications is essential for selecting a bearings in regulated industries. Involvement of bearing technologies. Advancement in bearing technologies such as ceramics materials coatings offer enhanced performance benefits. Hybrid bearings combine steel and ceramic elements provide improved durability and efficiency. Startup to a date with the last innovations in bearing technologies to optimize machinery performance. Bearing selection tools. Utilize online calculators, softwares, and Categories provided by bearing manufacturing for the accurate selection tools such as bearing selection guides. Calculating programs can assist in determining the most suitable bearings and applications. Take advantage of technical support for manufacturing to address the specific queries and ensure the right bearing choices. Case study success stories. Learning from a real world applications and experiments can help in making informed decisions. Analyze simple applications and outlines to understand the impact of bearing selections and overall performance. Training and education. Continuous training and education on bearing technologies and selection certains are beneficial for industrial professions. Attention workshops, seminars. Investing in employing the training and lead to improved decision makings and optimal machinery performances. Risk assessments and plannings. Establishing the productivity maintenance strategies and having a spare bearings on one and minimizes the downtime in case of emergencies. Supplier evaluations and relationship management. Selecting a renewable bearing suppliers with the track records to quality product and services is crucial. Building storage relationships with a supplier can strong relations with suppliers can lead to a better supporting processing and product availabilities. Regularly evaluate supplier performance and communication requirements to ensure the contest supply of high quality bearings. Real time monitoring and predictive maintenances. Implementing the real-time monitoring systems can predict maintenance technologies can enhance bearing performance. Conditions monitoring tools such as vibration analysis and thermal images can detect early signs of bearing degradations. Leave ranges data driven insights for predicting a maintenance enables proactive interventions to prevent unexpected failures. Continuous improper and feedback loops. Establishing a feedback loops for continuous improvements based on performance data and user feedback is essential. Analyzing bearing performances metrics and select input for maintenance terms can divide optimizing effects. Embrace a crucial or continuous improvements to refine bearing selection process and enhances overall equipment reliabilities. Conclusions and takeaways. Choosing the right anti-friction bearing requires a careful considerations of load speed, lubrications, and operational conditions. Optimizing maintenance installations and monitoring practices to ensure bearings longevity performances. Stay information about industrial trends, technologies, and best practices to make the informed decisions in bearing selections. Case plans, high implementation speed, outer rings, high temperature operabilities, lubrication grooves and holes. Cages, high strength, precise steel, specific surface temperature treatments. Rollers, increased case size and number. Inner rings, high temperature operabilities.